Well, hello, welcome to MOS Live. You are joining us just in time for our coolest science stories, where we'll be talking about some exciting science that's going on in the news, and we'll have a chance to take some questions from you about the four stories that we'll share today. Now, if you're joining us on Zoom, you can go ahead and start asking those questions anytime you'd like by clicking the Q&A button on your screen. If you'd like captions, you can access those by clicking the closed caption button at the bottom of your screen and selecting Show Subtitles. Now, if you're joining us on Facebook, unfortunately, we cannot see your questions right now, but we are thrilled that you're tuning in. Now, I am joined today by two other fantastic educators from the Museum of Science, and I'd like to ask them to join me now and turn on their cameras and their microphones and introduce themselves.
Everyone, my name is Becca. My pronouns are she and her, and today I'm going to be talking about some really interesting information about potential volcanic activity on Venus.
Hi, my name is Maida. My pronouns are she and her, and today I'm going to be talking about some updates on the smallest dinosaur.
Very cool. Very excited for those stories. Thank you. And my name is Megan. My pronouns are she and her. And I'll be starting us off with a story about a new way to identify birds. And then a little later, I'll be talking about a new breakthrough in the world of quantum physics. So let's get started. Now, how difficult is it to tell the difference between these two species of birds, a house wren and a blue jay? Well, it's not all that hard. The house wren is small and brownish, and blue jays are bigger and, well, they're blue. And they even sing different songs. But what if I asked you to try to find this particular blue jay in this group of other blue jays? Well, this is not so easy. It can be really hard to tell birds of the same species apart from each other. But this is actually something that scientists who study birds have to do a lot. They have to be able to tell different birds apart. Now, typically, to tell individual birds apart, scientists will fit them with a little numbered metal band around their legs, or sometimes colored bands, so that they can tell the birds apart by looking at them. But trying to identify birds this way can be pretty challenging and time consuming, especially when scientists have to identify a lot of birds, which is usually the case. Because in order to answer scientific questions about birds, like how long they live or how they behave, scientists need to collect a lot of data. But now, scientists may be able to get some help from artificial intelligence. Now, artificial intelligence is the technology that allows computers to do things that typically only living things like humans can do, like making decisions or using language or being able to see and perceive the world. And this usually brings to mind things like advanced robotics or self driving cars and even facial recognition software. But artificial intelligence is also really useful for applications in wildlife research and conservation. And now, an international team of scientists has developed a way to use the same type of artificial intelligence that's used to recognize faces, to recognize individual birds. It's a type of artificial intelligence called a neural network. And the neural networks that I'm talking about aren't used for our computer programs, but they're actually based on the way that our brains work. And artificial neural networks are particularly good at recognizing images of things. Now, for example, in this picture, these are two birds of the same species, and to us, they look really similar. But an artificial neural network can pick out really subtle differences between these two birds that we can't easily detect. And in this new study, they were able to develop a neural network that can recognize individual birds by looking at pictures of their backs. So here's what they did. They started by selecting two species of birds to study in the wild, a bird called a great tit and another type of bird called a sociable weaver. And they also studied one species of bird in a laboratory setting, a zebra finch. Now, In order to get their neural network to recognize individual birds of each of these three species, well, it can't just do this on its own. They have to train it to recognize the birds. And to do that, they need to show the neural network lots and lots of pictures of individuals of each of these three species. So to capture all those pictures that they need, for the wild birds, they fitted them with a little microchip called a pit tag. And then they attached an antenna that recognizes the pit tag to a bird feeder. And so, kind of like how a toll booth recognizes an Easy Pass tag inside a car, the antenna recognizes the pit tag on the bird. And then the antenna sends a signal to a computer that tells a camera, also attached to the bird feeder, to take pictures. So every time the bird lands on the bird feeder, this camera snaps a bunch of pictures of the bird. And they also used automated cameras to capture pictures of the zebra finches that they were studying in a lab. Then they did this over and over and over again until they had lots and lots of pictures of each individual bird for all three species. And they used those pictures to train their neural network to recognize all these individual birds. So by showing the computer lots of pictures of each individual bird, the neural network basically learns by trial and error to recognize all these individual birds. And it got pretty good at this. In fact, when they tested out the neural network, they found that it was about 90% accurate for each of the three species, which is pretty good because remember, the computer is not trying to tell the difference between these three different species of birds. It's trying to tell the difference between individuals of the same species, which is really hard to do. So this is a really great start. But the scientists who developed this new tool, they want to keep perfecting it so that it can be more widely useful to more different types of scientists. So there are a whole bunch of different challenges that they need to overcome in order to do that. And one of these challenges is just the changing of the seasons, because some birds, like this blackpoll warbler, well, they can change their appearance as they molt their feathers throughout the year. And this would make it really difficult for a computer to recognize the birds at different times of year. Now, artificial intelligence isn't going to replace important types of bird identification, like those bands around birds' legs, but it could be a really useful tool for certain types of researchers who are trying to learn new things about the lives of birds. And the more we know about birds, the more we can do to protect them in the future. All right, and now I am going to pass it over to Becca, who has our next story about volcanoes.
All right. Thank you, Megan. That was really awesome to see. Now we are going to talk all about Venus and all about some potential volcanic activity. Now, Venus is the second planet from the sun, one closer than Earth is. It is about the same size as Earth, but it's also extremely different from Earth. In fact, Venus is covered by really, really thick clouds and a thick atmosphere made up of gases that are not known to support life as we know it, but it is really interesting to study, mainly because it's very difficult to see through that extremely thick atmosphere. Luckily, NASA has developed a lot of technology, and one of those pieces of technology is that they've been able to send orbiters to the orbit of Venus to explore it a little bit more. This is Magellan. It was an orbiter that you can see here being launched from the Space Shuttle Atlantis in 1989, and it went to Venus in the orbit of Venus for 4 years, from 1990 to 1994. And during those 4 years, it was able to take radar images and map out much of the planet. So now we actually know a lot about what Venus looks like because of these amazing images that we've gotten. We've learned a lot about the surface, including some interesting features that, well, aren't that interesting here on Earth, but they're things that we see on Earth all the time and didn't maybe expect to see elsewhere, including what we believe to be our dome volcanoes, as we can kind of see over here on the left, and also lots of lava flows. In fact, Magellan found that upwards of 80% of Venus's surface is covered in lava flows. So are those new lava flows or are they old? Well, the problem is on Venus, it's a little bit harder to see. Venus doesn't have as much erosion as we have on Earth. And while erosion kind of makes our rocks go away pretty quickly and kind of recycle into the rock cycle, on Venus, these could have been there for millions of years. So are they currently geologically active features or past ones? Well, that was always a little bit of a mystery, but a study published just a couple weeks ago helped us out. Because here on Earth, in order to have volcanoes, we have to be geologically active, which we are. Our center of our Earth is moving. We have layers, some of them molten. And in the case of making volcanoes, we get some magma, some molten rock coming up through the crust, through the upper layer of the Earth in a few different ways. It could just come up in a plume, like how the Hawaiian volcanoes are made, and it just comes straight up through the crust, or it could come up when two plates are moving apart, sort of in the mid-ocean area, or it could come up when two plates collide and one goes underneath another one, melting some fluid and causing some volcanoes to pop up. But these all have to be on a geologically active planet. So is Venus geologically active? Well, again, this was a mystery, but the study that was published just a few weeks ago in Nature Geoscience shows us a little bit more of an insight. Scientists were specifically studying something called the corona or the coronae of volcanoes, which are sets of rings around the outside of what look like volcanoes from radar imaging on Venus. And then looking at these radar imaging and also being able to then look at some computer models that they made, scientists were able to determine what an active corona looks like versus an inactive one. And the active just means that it's either formed very recently or is still forming. They thought that if you could see the outer rise and also the trench of the corona, that would mean that it was an active corona, actively forming or recently formed. However, if you couldn't see that and could only see the rim or the inner high, then that meant that it was inactive, something that probably formed a while ago and would not really show any activity in the future. So based on all of this, scientists were able to apply this same theory to a lot of different corona across the entire planet based on the radar imaging that they received. And they determined that 37 of the ones they looked at were or are currently active. So that would either be recently or potentially still active. Now, of course, we would need to send something to the surface of Venus to make sure, but it's definitely interesting to notice how there are little patterns of where the activity is occurring. So maybe there is some sort of geological activity happening inside. Luckily, we'll be able to continue studying Venus as we develop more technology, and we'll learn a whole lot more about our sister planet. That has been our update on volcanic activity on Venus. I'm going to hand it over to Myra next, who will tell us about a dinosaur.
Thank you, Becca. That was really interesting. And so now we're going to talk a little bit about an update on the recently discovered smallest bird. Now, you guys may have seen that presentation where we talked about the smallest bird. And we talked a little bit about the fact that when we think about dinosaurs, smallest dinosaur. When we think about dinosaurs, we usually think of dinosaurs like T-Rex, Stegosaurus, and Triceratops. We don't usually think of tiny dinosaurs, and that could be for a lot of reasons, but probably because tiny bones tend to get crushed under sediment and just don't last this long. Now, we know that birds are descended from dinosaurs, and they're often referred to as modern dinosaurs. And the smallest bird is the bee hummingbird. And at 2 inches tall, that means it's also the smallest known dinosaur. That was until recently when we found a brand new skull that is old enough to be a dinosaur. It's 99 million years old. Now, this skull was preserved in Burmese amber, and just like anyone who's ever seen Jurassic Park knows, amber can preserve really tiny things for a really long time. Now, to preserve this specimen or to make sure that it stayed intact, scientists did a type of X-ray imaging to get this 3D image. And they named this new species Oculodentavis congre, which means eye-tooth bird. And at the time, that name made a lot of sense because This new species has very unique eye and teeth characteristics, and at the end of the study, scientists concluded that it was, after all, a bird. Now, if you watched that study or that presentation, you may remember that this new species had some very interesting characteristics. It had some bird-like characteristics, it had some dinosaur-like characteristics, and it even had some weird and random lizard characteristics. But at the end, scientists concluded that this new species was probably fell somewhere in between traditional dinosaurs like T-Rex and modern birds like our bee hummingbird. But ironically, a brand new study has taken a closer look and has realized that it's exactly those teeth and eyes that this dinosaur was named after that make this eye-tooth bird, well, not a bird at all. Instead, it's actually probably a lizard. So let's talk about why. Well, this is what scientists originally thought this animal might look like. And you can admit that it's absolutely adorable, but let's talk about those eyes and teeth, starting with the eyes, because the shape of the bones surrounding the eyes actually match those of lizards, and the original authors did mention that. However, there are a few dinosaurs that have similar characteristics, and so the scientists concluded that perhaps the eyes were just dinosaur eyes. But then let's talk about those teeth, which are a little bit harder to explain, mostly because modern birds don't have teeth, but we do know that early birds like Archaeopteryx did have teeth. However, nowhere near as much as this guy. And more importantly, the teeth were never fused to the jaw, because just like us, dinosaurs and early birds have teeth sockets where the teeth go inside of. But this new species has its teeth fused to the jaw, just like lizards do. Well, I really wanted to talk about this update because it shows us that with new science, our understanding of the world is always changing and evolving. Now, originally, all of the evidence, or most of the evidence, pointed towards birds. In fact, even computer algorithms that were given all of the data and all of the characteristics concluded every single time that this species had more bird-like characteristics than anything else. And yet, with this new study, even the original authors are convinced enough, or are considering it enough, that they have retracted their original paper. Now, we still don't know where Oculodentavis falls, but we do know that that just means we need more data. And thankfully, a brand new specimen of this exact same species was recently found. While that paper has not been published yet, when it is, we'll have even more information to make an even better conclusion. Now, this has been a little bit on the updates for our smallest dinosaur that might just be a lizard now, but I think we're going to go with Megan, who's going to tell us a little bit about AI.
Thank you, Myra. That was such a cool story. It's amazing how to hear about these updates and how scientists can unravel these puzzles from fossil evidence. It's really amazing. All right, but now we are going to shift gears and talk about a new development in the world of quantum physics. Now, quantum physics is the science that describes how the tiniest building blocks in our universe work, things like atoms and subatomic particles. And by studying quantum physics, scientists are discovering new exotic quantum states of matter. Now, we're already familiar with some states of matter, things like solids, liquids, and gases. In the case of water, we have solid ice, liquid water, and steam. And these states of matter can transition back and forth depending on the temperature, which is really just about motion. When the temperature cools down, atoms are moving more slowly. And these atoms make up matter, and they're moving more slowly, and they stay closer together. In the case of water, as the temperature cools down, we eventually get solid ice. Now, in order to observe these exotic quantum states of matter that I've mentioned. So we're talking about states of matter that are down at the teeny tiny scale of atoms and individual particles. Well, temperature is really important because we need to get down to really, really, really cold temperatures. Now, I'm not talking the temperature of your freezer or the Arctic. I'm talking way colder than that. We need to get down to temperatures that approach the limits of what's physically possible, down to what's called absolute zero. Now, down at these ultra cold temperatures, atoms move incredibly slowly, which actually makes it a lot easier for scientists to study them. But also, down at these ultra cold temperatures, these exotic quantum states of matter can emerge. And one of these is something called a Bose-Einstein condensate. And here's how it works. Now, as we approach absolute zero, atoms are moving so slowly that they're barely moving at all. And kind of like how the atoms that make up water condense to form solid ice, the atoms that make up a Bose-Einstein condensate condense to form one big superatom, all moving together in a single wave. And this coordinated superatom is the Bose-Einstein condensate. And scientists are super excited about studying these things because they think they might be able to use them as a tool to discover new things about atoms and particles, and maybe even things like dark matter and energy in outer space. But so far, Bose-Einstein condensates haven't been all that useful to scientists because they don't last very long. Now, scientists need to make Bose-Einstein condensates in a laboratory. And in order to do that, they trap a small number of atoms using magnetic fields, and then they have to cool them way down, almost to absolute zero, using lasers and other techniques that get the atoms really, really super cold. But doing these things in a typical laboratory setting, scientists have only been able to hold on to a Bose-Einstein condensate for just a small fraction of a second. And a big reason for this is because the Earth's gravity messes with all these techniques that they need to go through in order to get the atoms super, super cold. But there's a way to get around the Earth's gravity. You can go to space. And that's exactly what a team of scientists from NASA did. They created a Bose-Einstein condensate on the International Space Station. Now, back in 2018, scientists from NASA launched the Cold Atom Lab, and its mission was to use the microgravity environment of the space station to study ultra-cold quantum gases. And studying a Bose-Einstein condensate was on the very top of their list. And just recently, in a paper published in the journal Nature, these scientists from NASA reported that they were able to create a Bose-Einstein condensate on the International Space Station that lasted for over a second. Now, this doesn't seem like a very long amount of time to us, but to these scientists, it was a huge deal because it finally provided some proof that they could create these longer lasting and potentially more useful Bose-Einstein condensates by using the microgravity environment on the International Space Station. But this is just the first step. Now that they've been able to make these things on the space station, scientists want to make them even colder. In fact, the Cold Atom Lab on the space station is on its way to becoming the coldest place in the known universe. And that will allow scientists to hold on to these quantum states of matter, like a Bose-Einstein condensate, for a lot longer, so that they can finally try to use them to discover new things about the universe. All right. Well, that concludes our stories. And now I would like to invite the other educators to come back on so we can answer some of your questions. And we have a whole bunch of questions about Venus. So I'm going to start off with a question for Becca. And let's see, give me just 1 second here. All right. So Becca, what is the biggest volcano that they've found on Venus? And this is from Clement, age 9.
That's a great question. So the biggest one that they found so far, again, Magellan mapped most of the surface, but not all of it, is something called Maat Mons. I don't know if I'm pronouncing it correctly. It's MAAT. Mons. And so it was about 5 miles supposedly above the surface of Venus. Now, that's not the largest volcano in the solar system, and Earth isn't even home to that either. In fact, the largest one in the solar system is on Mars, and that's Olympus Mons, and it is no longer active. Awesome question. All right, and we have a question for Megan from Neil, age 8. Does the neural network get confused for the birds that haven't gotten tagged?
That is awesome. And clearly, someone is thinking like a scientist, because that is actually something that they looked at in this study. And it's one of those challenges that they need to overcome to make this new neural network more useful. So one of the things they found is that when birds who they haven't tagged come into the picture, their neural network doesn't work as well, because it can actually mistake these new unknown birds for birds that have been tagged and that the neural network has been trained to recognize. So that's something that these scientists really want to work on to make this new automated AI program for bird ID more useful. That is a super cool question. And now let's go with a question for Myra that I just saw and now have lost, and I'm going to find it. Here it is. So you talked about a really small new dinosaur, which is so cool and adorable, but what is the largest dinosaur?
So I believe that the largest dinosaur is the Argentinosaurus, and it can grow up to 130 feet tall, or at least that's what the fossils tell us. So that's insanely huge and a lot bigger than our tiny little Oculodontavis. So I have a question also for you, Megan. What is the coldest temperature that scientists can reach?
So scientists can reach really, really, really cold temperatures. And so the coldest temperature that we would know of is absolute zero. But for the most part, scientists say that that's not a temperature that we can actually reach, because that would mean that nothing, even atoms, are moving at all, which isn't really possible. So there's always just a little bit of motion creating a little bit of temperature. But scientists are actually able to get down to like just maybe like billionths of a degree above absolute zero. So really, 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 really super cold. And there's all these crazy techniques that they can use to get down to almost absolute zero, like cooling atoms down with lasers and letting them expand under really cold temperatures. And so it's so cool that they've now found a way to help that happen by going to space and doing this. That is a super awesome question. So let's see, we have more questions about Venus. And sorry, we have so many awesome questions. I'm just scrolling through here to find the next one that we can. Oh, so here's a great one. Becca, how do scientists see through Venus's atmosphere to observe the volcanic activity and take all these cool images?
Yeah, that's also a great question. And so Magellan was using something called radar. Now, radar imaging is kind of like a camera, only when you have a camera, you're looking at visible light, and the camera has a flash and it sort of bounces off things and it bounces back to the camera, and that's what you see. But in the case of radar imaging, they're using radio wave frequency. So it's kind of a different frequency. So they're able to actually go through the clouds, because the clouds don't really, it's able to get through there, and it kind of produces its own sort of light in the radio waves, and it bounces off something and comes back. And that's also how they're able to sort of tell how tall something is on Venus and map most of the surface that way. So it can kind of see through the clouds differently than a regular camera could. So that's definitely a really cool way that it does it.
Cool. Well, unfortunately, that is just about all the time that we have. Thank you so much for submitting all your awesome questions. I'm so sorry that we didn't get a chance to answer all of them. So now I'd like to give my fellow educators a chance to say goodbye.
Bye, everyone.
Bye.
Thank you so much to all of you for joining us today. We had so much fun. sharing these stories with you. And there's a lot more going on over at MOS Live. So check us out on our website at mos.org/MOS at home to see what we're up to, or check us out on social media. And if you enjoyed this program, please consider supporting the museum by visiting us at engage.mos.org/welcome to support our continuing online programming from the Museum of Science. And we had so much fun today. Thank you so much, and we'll see you next time. Bye-bye.